Hello everyone, and welcome to today's webinar on the Introduction to openLCA, the free open source software for lifecycle assessment. Our presenters today will be Sarah Cashman and Ben Young with Eastern Research Group. Before we get started though, I'd like to review a few housekeeping items. All attendees have been muted to minimize background noise. If you have a question during the presentation, please type it into the questions box on the upper right-hand side of your screen. And we will have a designated time to answer questions at the end of today's presentation. If you experience any technical difficulties, please type those concerns into the chat box as well, and we'll do our best to troubleshoot the issues. And with that, I'd like to turn things over to Sarah Cashman to get the presentation started. Welcome, Sarah.
Great, thank you, Amanda. Welcome everyone to our Introduction to openLCA webinar. We have assumed that attendees have a basic understanding of lifecycle assessment, and we will not cover LCA methodology in detail today, as we would like to focus on the software training. We will be recording today's webinar, and anyone interested in viewing the recording can contact us afterwards through email. So my name is Sarah Cashman. I've been an LCA analyst at ERG for about 10 years, working on a wide range of projects, from packaging studies to water treatment analyses to data management. I've been a user of openLCA since 2012, and I've seen significant improvements in the software and its features over time. My colleague Ben Young will be presenting the actual software demonstration today. Ben leads a number of our LCA studies in the energy sector and has expertise in developing detailed inventory data sets from publicly available sources. GreenDelta is a creator of openLCA. GreenDelta is based in Berlin, Germany, and works in all areas of lifecycle assessment and sustainability, including research and database development, as well as software development. ERG serves as the official US training partner for openLCA. ERG's Franklin Associates division has been conducting LCAs since it was founded in 1975. Franklin Associates joined ERG in 2003 and is fully integrated with ERG services. ERG has offices across the US. Ben and I are located in the Lexington, Massachusetts corporate headquarters. ERG offers a wide range of services related to climate change, air and water quality monitoring, solid waste, characterization, economic analyses, IT solutions, communications, and many more service areas. So during today's webinar, I'll briefly introduce the openLCA software and describe some main functions and features. I will also introduce the case study that will be the focus of our training. Ben will then walk through an interactive demonstration of the software. It is not necessary to have the software downloaded for the training session, although we will show you where you can download the software for free. We will save questions for the last 20 minutes. However, as Amanda mentioned, please enter your questions in the question chat box as we go along. So I will now introduce you to openLCA and review how you can download the software and supporting data. The openLCA software is a free and professional tool for conducting lifecycle assessment. It has similar features that you might find in a commercial software option, and has been making significant improvements and adding advanced features quickly, largely due to its open source code. Additionally, openLCA users have an active user forum on which to pose questions and feedback. Version 1.8 is the latest version that is available, and you can download that at www.openlca.org. All you need to do to download the software is to fill out a simple form, or you can just go directly to downloads. openLCA is available for 64-bit Windows, Mac, and Linux platforms as a desktop application. You can download the main software installer, which we recommend here. You can also download the zip file if you wish to maintain multiple versions, including older versions of the software. On the downloads page, you can also download other features, such as impact assessment methods, which are used to calculate LCA results from your developed inventory, or data quality systems, which score the data quality of flows and processes, allowing users to find indicators such as flow reliability, temporal correlation, geographical correlation, and more. You can also download the collaboration server here. The LCA Collaboration Server is a server application that complements the openLCA desktop application. It facilitates exchange of LCA data between users who work from different computers, enabling distributed collaborative LCA modeling. We won't have time to cover the collaboration server in detail today, but more information on this option is available on the openLCA website. So openLCA is just the software, and lifecycle data need to be imported. Various free and for purchase lifecycle inventory databases are available on the openLCA Nexus. You can also download impact assessment methods formatted for openLCA here as well. Many lifecycle inventory databases created for other commercial LCA software that have been formatted for openLCA can be purchased here. After selecting your database, the Nexus will let you know what versions of openLCA data has been created for. It will then download a Zolka file, which can be directly uploaded to openLCA as a database. Ben will demonstrate this later. You can explore other features of the Nexus. For example, within the map section of the Nexus, datasets can also be viewed by geographic region. Briefly, I will mention that while openLCA is free, you can also purchase help desk support tickets through the openLCA Nexus if you need additional expert support. US users may also reach out to us at ERG to inquire about support services. So we'll now briefly cover the main functions and features of openLCA. Flows are the main building block of an inventory model. Flows in openLCA can be for products as well as elementary flows. Processes in openLCA is where you define your inputs and output flows for a product. Product systems are process networks, which include all upstream results. You need to generate a product system to run your results. Projects are the top-level element and are used to compare numerous product systems. Within your navigation section, you can also download lifecycle impact assessment methods used to characterize the inventory values in your LCA results. openLCA has been built to support social LCAs and allows for use of both social LCA databases as well as indicators. Global parameters allow the user to define parameters that are available for use in any process. openLCA supports multiple data quality systems as well that can be imported here in your navigation pane. This diagram shows the general structure of the openLCA elements I just described. Processes are built from flows, product systems are networks of combined processes, and a project compares results across product systems. Here is an example of a process in openLCA. Inputs and outputs for each process can be added by clicking the green plus button here. You can build a product system from any process. Ben will demonstrate this shortly. Here you can see an example of the model graph generated for a product system, which displays all of the connected processes for the system you are studying. Once you have a product system, you can generate your results. In this example, you can view contributing results for both flows, such as individual inventory emissions here, or by impact category according to contributed process here. There are other neat features of openLCA. For each process that contains a flow, you can set a location which allows for regionalized mapping of inventory and impact assessment results. openLCA also supports Monte Carlo uncertainty analysis. Users can run uncertainty analysis based on the uncertainty criteria defined for flows within each process. The software also supports separate calculation of costs, regionalized and parameterized impact assessment, data quality results reporting, dynamic allocation selection, export to Excel, import-export for numerous file formats, and multiple languages. So now I'll introduce you to the interactive case study that we'll be building and generating results for today. So our goal will be to build an example lifecycle model for a bottle of spring water in the US. All the data that will be using the specific values will be mock data and are not for an actual system. We will source our upstream data from a publicly available database. We will demonstrate developing new processes and linking to existing processes. We will also show you how to parameterize flows, and we will generate impact assessment results. We will then compare different permutations of our bottled water analysis. So here is an example flow diagram of the system we'll be building today. We'll look at one 500 milliliter bottle of spring water that's made from PET plastic resin here. Our raw material will include both recycled and virgin content. We're going to demonstrate how to parameterize the amount of recycled content and look at different options for 0 and 50% recycled content. We'll also look at different weights for our main bottle. We'll do a mock heavier bottle with 20 grams as well as a lighter weight system of 10 grams. Our analysis will include other life cycle stages as well. We'll include the PET bottle converting, which includes the steps of preform injection molding and stretch blow molding, which both require electricity inputs. We'll also model the polypropylene and oriented polypropylene cap and label, and include the raw material and conversion processes associated with those components of the bottle of water. We'll also include treatment of the spring water that will go into the bottle, as well as loss of any consumptive use during the filling process. The treatment also includes refrigeration or electricity. Once the bottle is filled, we'll model distribution in a truck to the retail location, which includes the weight of the bottle and its components, as well as the weight of the water. We'll model refrigeration at retail. After use of the bottle, for the component of the bottle that is not recycled, we'll model disposal, either through incineration with waste energy combustion or landfill. We'll parameterize the incineration process as well. The current split that we'll model for waste energy incineration will be about 20% and 80% of the plastic going to landfill. This can vary greatly by regions across the US, for example. So this may be a parameter you wish to vary in your analyses. Again, the data we'll be showing you today is all mock data. It doesn't represent an actual system. In reality, your life cycle model would be a bit more complicated. You would have transportation steps and other processes associated with some of the inputs, but we're showing you a simplified model for demonstration purposes today. For a case study example, we actually uploaded publicly available data from the US Federal LCA Commons, which is another useful resource to know about. The Federal LCA Commons is a collaboration among federal agencies that are involved with life cycle assessment. This site was built in the openLCA collaboration server, which I described earlier. For example, today we downloaded the National Renewable Energy Laboratories US LCI database. In this case, we downloaded the full repository as a JSON LD format, which is another data type supported by openLCA. I will now turn it over to Ben, who will go through a live demonstration of the software using our bottled water case study analysis.
Great, thanks, Sarah. Everyone should be able to see my screen now, which includes the view of the openLCA software. So as we go through the demonstration today, as Sarah said, we'll be showing you a number of the most important features for generating lifecycle assessment results in openLCA. And as she said, feel free to answer questions as we go into the chat box, and we'll do our best to answer as many as we can following the demo. There's certainly a lot of features and a lot of advanced features that we won't be able to get to today due to our time constraints, but hopefully this gives you at least enough that you can get into the software and begin to explore on your own. As Sarah mentioned, there's a number of other great resources that are available to you on the openLCA website if you want to learn more. So the first thing that you'll see when you open up openLCA is this navigation window. You'll see that I have a database here for today's webinar that's already opened and populated with a number of different items. As Sarah showed during the slides, we have a number of the key openLCA elements shown here in the navigation bar, including projects, product systems, processes, flows, as well as a number of additional components, including lifecycle impact assessment methods and parameters, etc. So as Sarah mentioned, we went ahead and pre-populated the database for today's webinar in order to have enough time to show you some of the features. What we did is we started with a database that included all of the complete reference data for openLCA. So this includes all of the elementary flows and flow properties that might be used in a project. If you wanted to start your own database, however, what you can do is right-click anywhere within this navigation bar and do either new database to start from scratch, or you can restore a database if you have, for instance, purchased or downloaded something, a database or a data set from the openLCA Nexus. Additionally, as Sarah mentioned, if you have an existing database to which you want to add data or processes, one way that you can do that is within your database to right-click within the navigation bar and simply select Import. As you see, this will give you a number of possible data types of which you can import data into openLCA. As Sarah mentioned, one of the most common sources is linked data in the JSON LD format, where you can get a number of processes and flows that you've downloaded from a collaboration server have been shared by a colleague. Additionally, you can also import in Excel file format, EcoSpold, and a number of other file formats. One of the benefits of openLCA is being able to handle a number of these different file formats. So as Sarah mentioned, we have a database that we've set up here this morning. So it includes a number of processes and flows that we've downloaded from the US LCI. We can see them here in this folder structure. It includes things such as chemical processes for chemical manufacturing, oil and gas extraction, transport, a number of different manufacturing processes. We've also incorporated for today's webinar some impact assessment methods that we can use to understand what's going on within our inventories. So for today's webinar, we've downloaded from the openLCA Nexus, the US EPA's Tracy version 2.1 impact assessment methods. So that's what we'll be using today. In addition, we've also gone ahead and created a number of our processes for our bottled water project. Unfortunately, we don't have the time to be able to show each and every process, but we wanted to be able to show you a complete modeled system at the end of the webinar. So we'll make a few processes together, but we have a number of existing processes already built within our system, and so I've added them here under this folder for our bottled water project. In addition, we've also gone ahead and generated a few global parameters. As Sarah mentioned, here in the global parameters folder, we can see that we have a number of parameters that we can then use in any of the processes that we create. So this global parameter indicates that it can be used throughout our model and not just tied to a specific process or flow. So as Sarah mentioned, we'll go ahead and create a few processes within our model that are currently missing within our system. The first one is our process that will account for the amount of material input to our PET bottle. So what we'll do is, first we'll start by creating a new flow within our project. So if I right-click within the flows, I can select New Flow, and a pop-up window gives me some options for some information about this flow. I'm going to name this flow PET Bottle Raw Material Production. I could give this flow a description if I would want to. Then I'll need to select the flow type for this flow. openLCA has a number of flow types. Elementary flows, as you're probably well aware, are going to be those flows of things to the environment or from the environment directly. Product flows are typically the items that are going to serve as intermediate flows between our processes. We'll also show an example of a waste flow later in today's presentation. So I'll select product flow. Additionally, I'll need to select the type of reference flow property for this new flow that I'm creating. In our model, this is going to be not mass or volume, but rather number of items. So I'm going to give our flow here the reference flow property number of items. When I click finish, we'll notice that a new pop-up window shows here with our new flow that we've created. And it also appears down here in my navigation window, PET bottle raw material production. So if you're looking at the flow information, you'll notice that there's some additional metadata that you could include here for your process, such as a further description, a CAS number if it's appropriate, additional formula or synonyms. Additionally, that flow property that we set for our flow is listed here within the Flow Properties tab as number of items. So now that I've created my material flow that I want to model in our system, I'm going to create a process that handles this flow. So I can do that from the flow itself by clicking this button that's Create Process. And again, similar as before, it brings a pop-up window that enables me to provide some additional information for my process. So I'm going to name this process the same as the flow here, PET bottle raw material production. Notice that my flow is already selected as a quantitative reference for my process. I don't need to create a new flow, and I don't want this to be a waste treatment process, so I'm going to go ahead and click Finish. Again, we have a new pop-up window that shows up, and this time we have a number of new tabs for our process. So what I'll do is I'll walk through a few of these tabs as we go and give you some examples of what you might find in these tabs. And these are also some tabs that you can explore on your own. A number of these tabs refer to additional metadata that you might want to include for your process, such as the time period for which this process is relevant, the technology that's used in this process, where this process is located or what it represents, the location that it represents. Some of these other tabs represent additional data about the underlying source data, such as who generated or owns the data, if that's applicable, or the intended application of that data. Additionally, you can provide additional details on how the data were generated regarding treatment or modeling, sampling procedures, etc. But for our model, what we really are focused on is the inputs and outputs to our process. As Sarah described, processes as inputs and outputs handle flows. And so in order to make our PET bottle and handle the raw material for that PET bottle, we're going to need to add some input flows to our process. So in our model, that means we want to add input flows of virgin PET as well as recycled PET. So by clicking this plus button, I can add new flows as an input to my process. I can filter from my existing flows. So I'll look up virgin PET. Here's a flow that exists within my project already. And I'm also going to add as an input flow recycled PET. So we can see that two new flows have appeared within my inputs. You'll notice that as an output, my reference flow from which I created this process is already shown here. You also notice that it's in bold because this has been identified as the quantitative reference for this process. So any inputs or outputs that I associate with this process should be on the basis of my quantitative reference, or one bottle. So before we come back and assess some of the information for these exchanges within this process, let's jump to the parameters tab. As Sarah mentioned, we may in our model want to be able to toggle or change the amount of recycled PET content within our process. So we're going to add a new parameter to this process. And different from what we saw before with our global parameters, this parameter is only accessible within this process. So it's a process level parameter, which means that it can only be used within our PET bottle raw material production process. So as before, if I want to add a new input parameter, I can click the plus button, and we have a new parameter show up. Go ahead and label this parameter as rPET content, or recycled PET content. I can set the value. So let's say as a default, we'll start with 0% recycled PET, but this is a value that we can change later. It can be helpful to make sure we include some kind of description for our parameters so that we don't lose track of what it represents. I'm going to say that this is percent. It's the percent recycled PET content in our bottle. You'll notice that as I'm making additions to this process, that their little star will appear next to the name of our process up here in our viewfinder, and that simply indicates that we've made changes and this process needs to be saved before it can be used anywhere else. To save anything in openLCA, you can either use Control-S or one of these icons up here. So if I click Save, that star will go away, and I've saved any changes to my process. So let's go back to our inputs and outputs. Now that the parameter that we've generated can be used within our exchange flows. So when it comes to assessing how much virgin PET and recycled PET we want for our bottle, we can use a formula to calculate the amounts. So the amount of virgin PET that we want, here we can use a formula. We know that we need a total of 20 grams, which is based on our total PET bottle weight. And if you recall, that's one of our global parameters that we set up prior to this webinar, so I can use that global parameter within this process. When I start typing in the amount bar, any formulas or any parameters that exist within my database will automatically show up. For those of you who haven't used openLCA in a while, this is a relatively new feature and a really nice feature. Especially as you increase the number of parameters within your system. So I'll select my PET bottle weight, but I certainly don't want to have the entire bottle come from virgin PET, so I want to multiply that by my rPET content parameter that I just created. So I start typing, it'll show up, I hit enter. Oh, sorry about that typo. Alternatively, when it comes to recycled PET production, we can use a formula here as well. Oh, excuse me, this is a mistake. We don't want the amount of recycled PET, we want the opposite of that. Here we are. So now I have two formulas that will accurately account for the amount of recycled PET within our bottle. Now, if I want to assess or make sure that these formulas are accurate and catch any potential typos or mistakes that I might have made, this little toggle up here that shows 1.23 allows us to toggle between formulas and amounts. So currently I'm displaying formulas, but if I click this toggle, it's going to evaluate those formulas and show me the amounts. So based on my parameter within this process where I set recycled PET as 0, we see that this process is going to draw all of the necessary input flows from our virgin PET production as opposed to recycled PET. However, if I were to change that parameter within our process, say at 50%, now when I calculate show the evaluation of this formula, we see that the process is accurately updated to account for both virgin PET and recycled PET. Go ahead and save this process as I go. So we see that there's a number of other options within our exchanges here, additional data that we can provide. One of the things that we'll need to assess is our units that we want to account for here. As you may recall, when Sarah was describing our system, we're based on a weight of 20 grams, so we need to change our default unit to grams. Additionally, if you had data or wanted to incorporate life cycle costing, you could include things such as the cost of these material flows. We won't be incorporating that today. One of the nice features about openLCA is the ability to do Monte Carlo and uncertainty assessment. So if we wanted to add uncertainty values to these flows, we can select this field here and choose from a number of uncertainty options. So the default is to have no uncertainty ranges within our exchanges, but other options include using a normal distribution or a triangular distribution, uniform distribution, etc. So I could put a range, a triangular distribution, for instance, on that amount value if I would like. Finally, what we'll need to do is we need to tell openLCA for this process, where do we expect these flows to be generated? What process is going to provide these intermediate flows? And that's what this provider field is for. So if we click on this provider field, and we'll see a drop-down bar comes into view, and we can select any existing processes within our database that will generate virgin PET production. So in our model, we have a process of the same name that provides the flow of virgin PET. Note that this is a process, whereas here this is a flow. Similarly, I can select the default provider for my recycled PET production. Now, if I wanted to assess or make sure that these processes were what I expected, I can right-click on this exchange and open my provider that I've selected to view that within my window here. So now I've opened up virgin PET production to get a sense of what's going on with the inputs and outputs of this process. And so you'll notice that here we have as an input to this virgin PET production process that we've generated for this model, as an input we have the flow of polyethylene terephthalate resin at plant. So for each kilogram out of this process, we require a kilogram of PET. So let's go to this provider as well and get a little bit more sense of what's going on in this upstream process. So we can see that here within our polyethylene terephthalate resin at plant process, we have some actual underlying data to represent the production of PET. So as Sarah described, this data set came from the US LCI publicly available data set, but there's quite a large amount of metadata that we could dig into to understand what's going on within this process. What we're probably most concerned about, though, is the inputs and outputs, and we can see that for PET production, there's a number of intermediate flows, including materials and energy inputs for making PET, as well as a number of elementary flow outputs. These are things like emissions to air and emissions to water that take place during the PET resin production process. So we can see a much more complicated and thorough inventory for this process. And again, this data came from the US LCI that is available publicly. And one of the new features that was incorporated into this version of openLCA 1.8 that hasn't been present in the past, and that's quite helpful, is the ability to assess for a given process what is the impact assessment associated with that specific process. And one of the nice, so this tab down here, impact analysis, allows us to see for a given impact assessment method, what are the impacts associated with this specific process. So if we click on impact analysis, we'll see that openLCA calculates the impacts associated with PET resin at plant just from this direct releases from this process. We can even select alternative impact assessment methods. But the nice thing here is that we can identify which flows within our process are being captured and characterized by our impact assessment method. A common challenge in LCA, of course, is making sure that any emissions that we have within our system are accurately being characterized by our impact assessment. So this new feature enables us to do that within each process. So we could, for instance, compare our results here to those in our inputs and outputs to make sure that everything that we've used in our system is accurately being characterized by the LCIA. And that's a new feature in 1.8 that was just released within the last few months. So I'm going to back up here, back to our PET bottle raw material production. One final item that we'll show for this process is back on our general information tab. We have the option down here to be able to select data quality schema for our process. And, you know, in many LCA applications, it's important to have a sense for how confident we feel about the data that went into this process. And so openLCA provides some options for you to integrate a number of data quality indicators, which again, you can download from existing ones from the Nexus or from the openLCA website, or you can create your own. So for instance, we've included a number of data quality systems within our database. We have a few to select from here. So we can select, for instance, US EPA's process pedigree matrix for our process schema. So this would apply to the overall process, but we could also have a different schema for our individual exchanges. And so if we select, I want to input data quality for our process, we can select a schema and simply identify for this process, you know, what score do we want to give it over a number of categories. And as we'll see later, including data quality, openLCA provides a number of ways that we can use data quality to either assess uncertainty and or just to provide some data quality assessments when we run our results. So if you notice now for our inputs and outputs, we can also provide data quality entries here because we've selected a schema for data quality. And finally, it can be useful when we're working with processes to provide a little bit more information about a specific flow. This can help colleagues who are looking at the same model that you are understand exactly what you are doing or provide additional information that may not be clear. So we may want to include some additional description here, such as can indicate that it's in grams. So I will save my process. So ultimately, we now want to integrate this new process that we've created, the raw material for our bottle, into our much larger life cycle system. And so we have a process within our model that represents the bottled water life cycle. We'll jump to that process. We can see that on the inputs and outputs, we've already incorporated a number of flows within our system. So this would include everything as Sarah described, from the polypropylene label, the cap, the process of converting the PET plastic into bottle form, distribution from the filler to the retail, and the source water as well. And so we want to make sure that included within our system is the new process that we've just created. So as an additional input to our bottled water life cycle, I'll add our PET bottle raw material production. All right, and this is a reference flow of 1 unit, so we need 1 bottle for each complete bottled water. So we can keep that as it is. And as before, it's important that I select the provider for this process. So now I've updated my bottled water life cycle, which I'll use later to run results. So you may notice that in our life cycle as well, we also have a process to handle the disposal of the bottle. So let's take a closer look at what's going on there. We can right-click and open provider to view a little bit more detail about this process. So we can see that in our bottled water disposal process, for each bottle of water disposed, we have 2 possible outcomes for that bottle currently. One is that it can be sent to recycling, and we'll see that the amount sent to recycling is based on the PET recycling rate, a parameter that we've set, multiplied by the weight of the bottle. We also have some of the bottle that's being sent to the landfill. So this is based on the total weight of the bottle as well as the weight of the cap and the label. But as Sarah described in our model, we also want to account for potentially waste-to-energy incineration. And so what we'll do is we'll make a new process to account for plastic resin incineration. And I'm going to show a slightly different way to create a process as an alternative to the way we turned it the first time, where this time we don't necessarily need to create a new flow first, but rather can make a process directly. So if in my folder structure, if I right-click on the processes, I can click Create New Process. Let's name our process Plastic Resin Incineration. And this time I do want to create a new flow for the process. I don't yet have within my database the product flow or the intermediate flow to account for plastic resin incineration. I haven't made it yet, so I want to go ahead and create a new flow for this process. Additionally, this is a waste treatment process, so I need to select this box as well. We'll simply call our reference flow, same thing. And the amount of plastic resin incineration that we're going to be handling is going to be based on mass in this case. So we want to have our reference flow for this process to be mass-based. That's based on our underlying data here. So when I click Finish, not only has it made a new process, but if we were to scroll down here, we'll see that we've also generated a new flow. So plastic resin incineration is down below. I'm going to go ahead and move this flow into my folder. So this plastic resin incineration process, we can now add some of our data to understand what are the inputs and outputs based on incinerating plastic. And we'll notice a slight change here to how this process appears from the start. While in the other case, our quantitative reference was an output, we were making a bottle. In this case, because this is a waste process, the waste flow as a quantitative reference is an input. So this process represents inputs and outputs associated with incinerating 1 kilogram of plastic resin. So that's going to be an input, and that's what's different about these waste processes. So based on our underlying data, we're going to have 2 outputs of our process. The first output is going to be an elementary flow. We're going to account for the amount of carbon dioxide that's released during incineration. And so I can either search for it within my folder structure. We see all these flow folders have appeared, or I can simply start typing. We have a number of categories from which we can choose. Without further data, I'll go ahead and just use the emissions to air unspecified subcategory. Notice that elementary flows are indicated by this little leaf next to the F, where we saw waste flows are indicated by a broom symbol next to the F, and our intermediate flows, our product flows, are indicated by the F with the gears. So our data suggests in our model that for each kilogram of plastic resin that's incinerated, approximately 2.2 kilograms of CO2 is emitted. Notice that there's no provider needed here. This is an elementary flow, so there's no need to add a provider of a flow. And finally, because this is a waste-to-energy process, I also want to incorporate some electricity that's generated due to the incineration of the plastic resin. So I'll create another output. So as I start typing, I see that I have a number of possible flows up here. What I want to do is suggest that there's an amount of electricity that's created for the grid based on this waste-to-energy process. So I'll select this product flow of electricity at grid. And the data in our model indicates that for each kilogram of plastic resin that's incinerated, approximately 1.2 kilowatt hours of electricity is generated. So I'll add that here. Make sure I indicate the right units. And now, because this is a co-product, essentially, that we're generating, we want our system to earn a credit for any electricity that's generated during the waste to energy process. And so if we select this avoided product burden, or avoided product box, excuse me, our system will now receive credit for any electricity that's generated. But openLCA needs to know what is the source, or what is the approximate emissions associated with this electricity. And so in this case, we do have the need to select a provider. There's now an option to use provider. And so we'll use our electricity process, which will estimate the amount of the credit earned for each kilowatt hour of electricity generated through waste to energy. So this process is now complete. For each kilogram of resin that's incinerated, we have an emission of CO2 as well as a amount of electricity generated as an output. So I'll go ahead and save this process. But we want to make sure that the process that we just created is now incorporated back into our bottled water disposal. So I'll come back to this process and make sure to incorporate that. You'll notice that on our parameters for this process, we already have some parameters here to account for the amount of waste that's sent to waste energy. 20% is sent to is incinerated, while the remaining 80% is sent to landfill. And so as before, we have some input parameters, but here we show an example of a dependent parameter. So the percent that goes to landfill is a dependent parameter. It's not one that we set, but rather is based on another existing input parameter. So we want to make sure that we're only handling no more than 100% of the total waste. So we make this landfill parameter as a dependent parameter. So I'll jump back to my inputs and outputs. As a third option for our bottled water disposal, I want to add not just landfill and recycling, but my plastic resin incineration. So for the amount that's sent to waste to energy, the formula here is going to get a bit complicated, but that's okay. Total bottle weight after accounting for the amount that's sent to recycling, plus the weight of the cap, plus the weight of the label. And then in this case, we want to only account for the amount that's sent to waste energy. So let's double check that I included that formula correctly. Looks like I did. This seems to add up to about 22 grams or so, which is the combined weight of our bottle, our cap, and our label. Of course, I want to make sure I set the units correctly. So I'll change that to grams. And just like before, it's important that I identify the default provider of this flow. Where should openLCA send this flow that we've created? So plastic resin incineration. In many cases, you'll notice that we've named our process the same as our flow, but that's not always necessary, and there may be times where you might have multiple options of providers to choose from for a given flow. All right, so we've created our two new processes to complete our model. Go ahead and move this up. So a few other features that I want to show before we run the results of this model. The first is we were looking at our global parameters earlier. So let's take a closer look at those down here. We have a few parameters already created in our model. one parameter that we've created is one called PET bottle select. So this, for instance, is an input parameter where we can use this as a toggle to generate scenarios. So we know that in our model we want to run a plastic bottle of water that represents our baseline weight of 20 grams, but we may also want to run a scenario that's light-weighted, where the weight is only 10 grams. So what we can do is create an input parameter that where we can change or toggle this scenario. If we look at our PET bottle weight global parameter, we'll see that this is actually a dependent parameter, and its formula or its value is based on our PET bottle select. And so what we can use is anytime we use this PET bottle weight, as we saw when generating those processes, we can easily change or toggle that value based on a third parameter here, PET bottle select. So that's one way that you can use these parameters to effectively generate different scenarios and assess scenarios more quickly in your results. Anytime you anticipate using a value, the same value multiple times within your model, it can be useful to use a global parameter, and you can simply reference that parameter multiple times throughout your model. Another new feature that is in version 1.8 that's really nice is this parameter view window. So under window, you can select parameters, and openLCA shows you every parameter that exists within your database. You'll notice that we have a number of global parameters that we just saw, but it also shows any parameter that exists within a specific process. So we see that our new parameter that we created for recycled PET content is there. We see some of the other parameters we showed for our waste to energy percent or our recycling rate. And we also see a few other parameters within our model that we didn't get a chance to look over. But this is a really nice feature to not only see the parameters in your model and review what you have as your default settings, but you can also quickly change parameter values within this view simply by clicking on a parameter and right-clicking Edit. And you can quickly change the value of that parameter. So this is a really nice feature. So as well, before we run our results, I also want to jump down and quickly look at our life cycle impact assessment methods that we incorporated into our model. As I mentioned, we are using a version of Tracy 2.1 from the US EPA, so some of these impact categories should look familiar. But openLCA gives you the option to edit these impact assessment methods. You can add new impact categories. So for instance, I've added some new impact categories here to account for total inventory of solid waste, for instance, as well as a total amount of water consumption. These were not two that existed in Tracy before. And of course, you can also edit your impact assessment factors, your characterization factors. So for instance, under global warming, I could go into my impact assessment and identify, for instance, whether I want to account for biogenic CO2 in my impact assessment. One of the nice features about openLCA is not only can you change your characterization factors for impact assessment, but you can even parameterize these. So for instance, you could create a toggle where the carbon dioxide biogenic characterization factor might depend on a parameter which doesn't currently exist in my database, but we could create a parameter here. So you could quickly toggle that feature on and off and assess how your results might vary based on these different sets of characterization factors. And you can really have an unlimited number of impact assessment methods and versions of impact assessment that change. So let's move on to see what it looks like to generate results. I'm going to jump back to our bottled water life cycle process. So this was the process that was in blue on our initial diagram. This is our reference process for our product system. This is sort of the end point of our model. And the reference flow for which we want to generate results for. So our bottled water life cycle, 1 unit to 500 milliliter bottle of water. When I come to this process on the General Information tab, I can have an option here to create a product system. So as Sarah described, product systems are the links between processes. So I'm going to name my product system. This is a 500 milliliter bottle. We're going to start with the 0% recycled content. So it's good to name that. My reference process is already selected. And here openLCA gives you a number of options. And again, for users who haven't used the software in a while, these have changed to some extent and made things a lot easier when it comes to generating product systems. The first option here is whether we want to auto-link processes. So this is openLCA asking us if we want the software to make the connections between all of our processes. So you don't necessarily have to do this, but it's often much easier and much faster, and we'll take a look at what happens if you don't auto-link processes. But this is a way for openLCA to link all your processes based on the flows that are included within them. Another option here is we can identify whether we want openLCA to only use default providers, ignore default providers, or prefer default providers. So earlier we were selecting the provider within the processes that we were creating. If we hadn't included the provider and, for instance, used only link default providers, then openLCA would not move our model any further than that process. If no default provider were selected, it would not include any of the supply chain for that flow. So this gives you some flexibility based on your understanding of your own data and whether you want to include the default providers or not. So sure, we'll use default providers. So I click Finish, and we have a new product system here in our folder. It includes some additional data about how this process was created. It includes some reference data about the reference flow from our process. In this case, we have our product as a bottled water life cycle. There's only one. There are no co-products for that system, so only one is listed here. And again, if there were other flow properties such as mass or energy, we might be able to choose among them here, but that's not the case for our model. So on this Parameters tab, we can adjust, if we want, any of the parameters within our system. So as we saw before, we have a number of different parameters within our model, and we have the option here to deviate from the default. Because we identified this as being a 0% recycled PET, and we want to use our baseline weight, it's good practice to incorporate those parameters and set them in case the default parameter values have changed. So our content, again, we want to make sure our recycled PET content is 0 and that we're using our baseline weight. This is that scenario toggle parameter we looked at earlier. So I'll save. And then finally, we can take a look at the model graph. This is a way to view how your model fits together. You'll notice that this is our only one process is shown here. This is our reference process, but we can click on these plus boxes to view what's going on before and after our reference process. So we'll see that we have 6 different inputs to our bottled water life cycle, and those should look familiar from what we saw in our process itself. And we can quickly build out and see what's going on in each of these upstream processes if we want to see how everything fits together within our model. Of course, as models get more complex, another way to do this is simply to right-click and select Expand All, and we can see all of the different connections between processes within our system. It's not surprising to see how quickly our model can become quite complex with a number of links, hundreds and thousands of links between processes. So you'll recall that we told openLCA to auto-link our processes, and one of the reasons for that is it would be quite tedious to come in and connect each and every one of these processes manually, but that can be done as well. So we'll see that each one of our processes has a number of input processes, and the supply chain for some of these can be quite extensive. So you may recall, here's our PET bottle raw material production process that we just generated together, and here are the two inputs that we identified within our system. We could even trace these back as far as we want through the supply chain. So from this product system, we can go ahead and calculate our results. If I click calculate, I'm on the correct reference product and flow property. So if I calculate, it gives me a few options for what I want to do within my results. It gives me a choice of impact assessment method. So if I want to use impact assessment, I can initiate that here. If I wanted to use normalization and weighting, I can indicate that here as well. Sarah briefly touched on how we can run Monte Carlo simulation, so that's an option here. If you have incorporated uncertainty into your processes, you can run Monte Carlo. We also described how if you had incorporated data quality, openLCA will give you a summary of the data quality from all your processes. That's based on how often those processes appear in the flow of those processes. So we'll go ahead and just run a simple analysis. And we see that a number of new options show up for our analysis of our system. The first option here is simply just looking at individual flows. What are the top contributors for a selected flow? So we could, for instance, look at nitrogen oxides to see what are the processes within our system that are the primary contributors of nitrogen oxides. So just a simple bar graph here. Alternatively, we could look at impact categories. We could look at acidification. See pretty similar results here. What are the processes within our system that are driving acidification? Well, it looks like refining of crude oil is a primary contributor. We can, of course, also look in more detail and see our full inventory. Here we have a full inventory of all the inputs within our system. So these include a number of cutoff flows, some resource flows, energy flows. Here we have the full suite of outputs within our model. We can sort these by mass, for instance, or by category. As well as a total requirements matrix, which indicates for each of our processes how much in total was called of that process. Under impact analysis, we can see for the impact assessment method that we chose in our system, we can see the net results for our bottle. So for instance, our bottled water model system has about 0.264 kilograms of CO2 per bottle of water. We can also dig a little deeper and see which process is driving or contributing to this impact category the most. So we see that coal-fired electricity is a large contributor. Some of the other electricity processes, natural gas, some of the extraction processes for our fuels. Here's our plastic resin incineration process that we created. We can see that it contributes a non-negligible amount of CO2 to our overall system. And we can dig in a little bit further to each one of these processes if we want to see the specific flows that are contributing the most to that total. Alternatively, we could also uncheck this box subgroup by process and simply look for contribution by each flow, no matter which process it's coming from. So here we see that CO2 is the primary contributor to our GW, our global warming impact. And this is a good example where you have to be careful about your data because in our life cycle inventory we have a number of different flows that may or may not be similar flows, and so it's always good to these kind of things happen quite a bit in software like this, and so keeping track of the different flows. But in the end, both are calculated correctly for the impact factor, so we're okay. I won't have a chance to go through each one of these tabs, but one more tab that we can look at. We saw earlier a second ago that electricity is a large contributor to our total global warming impact. However, we also know that electricity is used throughout our supply chain in a number of different processes. And so the question might become, well, where is the electricity being used, and which of our life cycle stages is most responsible for that global warming impact? So the contribution tree is a nice way to view or answer that question. This allows us to drill down by process within our model to see where that impact is coming from. So I'll select my impact category. And here we can see sort of our high-level impact results by life cycle stage. So here we see that the PET bottle material production itself is about 61% of the total GWP, and that's coming from the virgin PET, drill down further, the PET resin, and we can see that there's a number of contributors within the PET resin itself, including electricity and diesel combustion and other material inputs. So this is a nice way to see by life cycle stage where are the impacts taking place. And finally, when it comes to results, one of the nice features too is you don't have to keep things in openLCA. You can also export your results to Excel and do additional manipulation or analysis in Excel. So we're almost wrapping up our demonstration. The final thing that I want to show here, I'm actually going to jump to a different version of our database. So I'm going to close my database here and jump to a version that we've already created in the past that has multiple product systems. This is our same model to show this project feature that Sarah mentioned before. What this does is it gives us a chance to do high-level comparisons of multiple product systems. Perhaps we want to vary some parameters and do some scenario analysis, and the project is a nice way to do that. So we won't be able to get into all the details of this feature, but what you can see is that we can select specific impact categories that we want to look at in further detail. We can identify specific product systems that we want to focus on for our analysis. So here we have both our typical regular bottle as well as our light-weighted bottle system. We can add in additional parameters that we want to vary within our system. And so in this case, we want to do 3 comparisons, 2 with our baseline weight and 1 with our light-weighted bottle. But for one of these versions, for our baseline weight, we want to increase the recycled content to 50%. So we can have 3 different scenarios here. So if I run this report, we can see that it gives me some preset options here, or some preset descriptions here that we can edit in our project. But we can see that it shows some high-level results for our comparison, including impacts for each of our scenarios. We have some graphs here that show have an ability for us to toggle between different impact categories to see how our scenarios differ based on the impact categories that we've selected. We have the ability to do process contributions, so we can look at specific processes that I've identified within my project and see what is the contribution for each. So let's look at net water consumption. We can see that unsurprisingly, the amount of treated spring water in each case is about the same, this red bar, but the electricity that goes into each is different and therefore results in a different amount of water consumption for each of our scenarios. And then finally, here's an example of another kind of graph that this report feature can show, where it can compare across impact categories between our 3 scenarios. And one of the nice features about this report view, and I know I'm going through it kind of quickly though, is that you can take this report and export it as an HTML file. And so it's a nice way if you want to show high-level results or share those high-level results, perhaps with someone who may not be familiar with openLCA, you can export those results. And as an example, it will look something like this. So now we have an HTML file that looks just like what we had seen. That's dynamic. and shows some results that we can toggle between as an HTML file. That's a nice feature for sharing results. So we certainly want to make sure that we have enough time for questions. We've gone through a lot of the features today, and I know we have a number of questions that come in. So what I'm going to do is turn things over to Amanda, who's been viewing the questions as they've come in, and we can see if we can provide some answers to folks.
Great, thanks, Ben. We do have some questions that came in, and I'll just read some of those. So the first one we have here is, do you recommend using data from different sources? Example, importing LCA Commons data into the EcoInvent database?
Sarah, do you want to address that, or should I?
Yes, and I can talk to that point a bit. So we didn't get a chance to discuss, recommendations for how to use data today. There were a few questions I saw on the data, so let me actually share my screen again here. So here is an example of the nexus, the openLCA nexus, and we showed this example as well as downloading from the Commons in our presentation. Now, openLCA, like any other software, you need to be careful about the data that you've used and how to harmonize the data. So in some cases, there are sort of self-contained databases. For example, EcoInvent, different versions of EcoInvent you see here. Version 2.2 as well as version 3 are available for purchase through openLCA and have been formatted. And you may be able to work within this as a self-contained database. Similarly, Gabi, for example, there's a version of Gabi that would be available through openLCA as well. So many of the commercially available data sets that you may find in other softwares are also available through openLCA. In some cases, you may consider using multiple sources. For example, if your model is supposed to be representative of a specific geography, like North America, and you want to use one main database and supplement that with alternative data sets for North America that you may not find in your main database. If you're doing that, you just need to make sure that the boundaries and scope are the same between your data sources, and harmonize the data sets. And I could probably talk about that topic for a few hours, but sort of caveats on using data sets together. It's always an option. openLCA, again, is just a toolbox to use, and you have the ability to use many of the same data sources that you might find in different LCA software options that have been formatted specifically for openLCA.
Thanks, Sarah. We have another question here that says, why does it take so long to run a Monte Carlo analysis in openLCA? Is there a way to reduce this time?
Right, so it depends on what version of the software you're working in. I know the time has probably improved over time, and you can set, in openLCA, you can set the iterations for your Monte Carlo analysis. So if you're running more iterations, it may take longer. It also depends on the complexity of your supply chain. So if you're running a fairly simple supply chain, it may not take that long. If it's a more detailed supply chain, or if it's connected to a database such as EcoInvent 3, which may be more complex, it may take a little bit longer. For the Monte Carlo analyses, sometimes it makes sense to run a few of those overnight and get your results, depending on how complicated the model you built was.
Great, thank you. Another question is, Besides inclusive data sets, what are the basic advantages of going for the premium softwares like CIMAPRO or Gabby over openLCA?
openLCA has many of the same features as other software options. As I was just showing you on the Nexus, many of the same data sources available within CIMAPRO and Gabby are also available and formatted for various versions of openLCA. I think a lot of it is user preference, just in terms of the interface is, you interact with the interface differently. So I would leave it at that in terms of different practitioners may be more used to working in one software. As I mentioned, openLCA and been demonstrated today, openLCA has improved a lot of the functions and response time in recent years. So a lot of it comes down to user preference, and again, many of the same data sources are available across multiple software platforms.
Great, and in line with that question, a very similar question, but we have a DataSmart database for CIMAPRO. Can we use the same database for openLCA?
You'd have to check the openLCA Nexus. I did see some release about DataSmart being available for openLCA, but I'm not sure about the status. So you can check back with the provider of DataSmart on the status of whether they have a database that's been formatted for openLCA.
Thanks. Another question here is there a max number of scenarios that you can compare within a project?
I haven't run into that. It may come down to, the number of bars that you can show on screen and communicate your results. But I haven't experienced that. Have you, Ben?
Yeah, not that I know of, but I would agree that you certainly don't want to, the project feature is a way to show high-level results, compare across scenarios, like you said, and certainly doing too many at once would make it a little bit difficult to view the results. But I don't think there's actually a limit.
Good to know. Another question here, which impact assessment method is available to estimate cumulative/primary energy demand for the US LCI database?
The method we showed today was essentially just a cumulative inventory of the energy flows that were going into our model. It wasn't, we showed results with the EPA Tracy impact assessment method, but we included a few inventory categories such as energy demand, which is an adapted version from EcoInvent, and Ben demonstrated how you can go in and adapt impact assessment methods. One of the options is to create new categories, and in our case, we just did a cumulative accounting for the energy flows going into our system based on the heating value of the energy resource at point of extraction. So it will take, it may take a little bit of work on the data side, but that's always an option in openLCA if cumulative inventory items such as solid waste generation or water inputs, et cetera, are of interest for your analysis. You can create those quite easily. You can run your inventory and see what flows are contributing, have energy associated with them, and then create such a cumulative inventory accounting. So that would be one option. It would take a little longer to demonstrate that today.
Thanks. Someone's wondering if they have an older version of openLCA and they want to upgrade it to 1.8, do they need to start all over, or are you aware of a way to re-import data sets?
You can just run the openLCA installer and it should automatically install the latest version. If you have older versions of the databases, you may need to convert that to the openL openLCA 1.8 format, and you will want to check that those all converted correctly. Alternatively, if you want to make sure that your project versions that were created in an older version of openLCA are saved, there was an alternative option that I displayed of installing the zip files, and then you can run multiple instances of different versions of openLCA from your desktop.
Thanks. Another person is wondering if it's possible to link parameters to Excel spreadsheets.
Yeah, that's a good question. I guess the short answer is no, not directly. There are a number of advanced ways that you can work towards a system where you have really complex parameter scenarios that sort of get into some of the more advanced features, such as linking with Python or using SQL commands to try to integrate some sort of external data sources. So there are ways to get at some of these issues or some of these advanced features, but they take a little bit more understanding of how the software works. Sarah, anything to add there?
No, that sounds good. You can import and export the process files as Excel files, which Ben, you showed briefly the command to do that.
Right, and that's true. That's another place where if you have a number of complex calculations, it can be helpful to export to Excel and do your calculations or changes externally and then re-import as one option.
Someone is wondering, is there a way to show the results of a group analysis? For example, integrating the results of electricity, waste, transportation, etc.
Yeah, so there is a grouping tab on the results display that gives you some options for combining processes together to be able to show those results together as you describe. To some extent, it's going to depend on how you've set up your model and how you've laid out your model in terms of the best way to do that. But yes, you can group processes together and see results for a collection of processes on the grouping tab.
Great. Someone else is wondering about how water consumption LCAs compare to other impact categories.
Right, so we included water consumption as just a cumulative inventory category and not as an impact assessment category. There are impact assessment categories that cover water, such as AWARE's water scarcity, which essentially applies a water scarcity index to your water consumption values. We would just caution when you're showing your results, if you do include cumulative inventory categories such as energy demand or waste generation or water consumption, that you clearly state that those are inventory categories and don't include characterization to impact assessment methods. And again, there are available impact assessment methods to take that water consumption result and convert it to water scarcity factors based on the watershed that flow occurs.
Okay, thanks, Sarah. I think that's it for the questions that I'm seeing. If you see any that I missed and want to address, please go ahead.
No, I think we covered it.
Great. Do you want to wrap up the webinar?
Great. Well, we're all set for today. Here's our contact information, our phone numbers and email for Ben and myself. As we noted at the beginning of the presentation, if you're interested in a recording of this, please contact us via email, and we can send you a link to the recording. Again, the information that we shared today was based on mock data. It doesn't represent an actual system. And so we're recommending it not be reproduced, for example, for an actual bottled water assessment. We also have, for general inquiries or overall openLCA support in the US, you can also contact us at openLCA@erg.com. So thanks very much, everyone, for joining today.